Write an equation for the polynomial graphed below. In order to create an equation for this polynomial, what we need to do is just find a place to begin with something that we comfortably know. For instance, one easy thing is to identify the zeros of the polynomial. So the zeros of the polynomial are the locations of where the graph touches the x-axis or crosses through the x-axis. So I have zeros at x equals -4, at x equals -3, and at x equals 1. But in addition, if I look at these zeros on a local level, at 4 the graph just crosses through the x-axis there, and the same for -3. So that means these are both zeros of multiplicity 1. But at +1, the graph touches the axis and bounces back away. It looks more like a parabola. Parabolas are degree 2 polynomials, and so we say this is a zero of multiplicity 2. The total of our multiplicities will give us the degree of the polynomial, and that's great because the polynomial here starts in the positive direction and ends in the positive direction. So that's consistent with a polynomial that is of even degree, and because 4 is even, that matches up. So that's very nice. Now, the next thing that we should notice here about the end behavior is that we're starting in the positive direction and ending in the positive direction. So any leading term coefficient that we come up with should be positive as well. Now, to take zeros and make a polynomial from it, what we will do is just take the zero, and instead of having it solved for x, we just, in this case, add 4 to both sides and make it a factor of x plus 4. Because if you have a factor of x plus 4, you have a zero of -4. Likewise, we would have another factor of x plus 3, and finally a factor of x minus 1, but because of the multiplicity, that term will get squared. The last thing to figure out is the leading term coefficient. And to figure out the leading term coefficient, all we do is just put a value in for that leading term coefficient and use some point on the graph that's relatively easy to see and solve for the leading term coefficient. So for instance, I can pretty easily see this y-intercept here, which is located at the point 0, 1. And so the f of x value is y, so I'll just replace that with 1. So we'll say this is 1 equals a times the x-coordinate of this point is 0, so 0 plus 4 is 4, 0 plus 3 is 3, 0 minus 1 is -1, but when we square that it becomes +1. So essentially I have 1 equals a times 12, or my leading term coefficient is 1/12. So that means my polynomial will look like 1/12 of x plus 4 times x plus 3 times x minus 1 quantity squared. And that there is the exact polynomial that will produce this particular graph.